Okay, let's unpack this. Welcome to the deep dive. Today, we're plunging into something absolutely foundational, not just for understanding the vast atmosphere around us, but specifically tailored for you if you're, navigating those challenging ATPL theory exams.
That's right.
We are undertaking a concentrated deep dive into the world of atmospheric pressure.
Yeah, and it's hard to overstate just how fundamental this topic is. Our source material for this deep dive, states very clearly that the study of atmospheric pressure may be said to form the foundations of the science of meteorology.
Wow.
So for anyone who flies, or learning to fly, understanding how air pressure works, how we measure it, and why it's constantly changing is, well, it's non-negotiable.
Definitely.
It's particularly critical when we talk about altimetry, how your aircraft's instruments tell you how high you are, and also understanding the forces that drive weather systems.
Exactly. So our mission for this deep dive is laser focused.
Sure.
We're going to take the provided material and extract the absolute core knowledge nuggets. We want to build a robust understanding of what atmospheric pressure is, the tools we use to measure it, the reasons behind its variations, and crucially, for your exams, those specific aviation pressure settings, QFE, QNH, QFF, and SPS. We're sticking strictly to the insights and definitions presented in the source material we've got, the one discussing atmospheric pressure, its measurement, its variation, and providing these definitions and examples.
Yeah, no going off piste here.
Exactly. This isn't about going outside the provided text. It's about mastering what's in front of you.
Think of this as your guided tour through the essential concepts you need to grasp this topic thoroughly, focusing on the practical and theoretical knowledge points that are, well, most likely to pop up in an exam context.
Perfect. Let's jump right in then and start at the absolute beginning. Understanding atmospheric pressure. What is this invisible force that we're talking about?
Well, the most precise sort of scientific definition, straight from our source material, defines atmospheric pressure as the force per unit area exerted by the atmosphere on any surface it's in contact with.
Force per unit area.
Yeah, it's literally the pressure exerted by the immense weight of the air pushing down on everything.
Right, force per unit area. That's the physics definition. But the source also gives us a way to visualize it that might be more intuitive, something about weight.
Absolutely. And this conceptual understanding is incredibly powerful for grasping why pressure behaves the way it does, particularly with height. You see, the source explains you can also think of atmospheric pressure as the weight of a column of air of unit cross-sectional area directly above a surface.
Okay.
Imagine a tiny square meter on the ground, or on the wing of your aircraft. Now, picture a column of air, exactly 1 square meter wide, extending from that surface all the way up to the very edge of the atmosphere.
Right up to space.
Pretty much. The pressure exerted on that square meter is simply the total weight of all the air molecules stacked up in that column above it.
Ah, okay. So it's the sheer mass of the atmosphere above you pressing down. Force per unit area, or the weight of the air column. Got it. Why is it important to understand both these definitions? What do they immediately tell us?
Well, they immediately lead us to one of the most fundamental and critical facts about atmospheric pressure, especially for aviation, how it changes with height.
Right.
If pressure is the weight of the air column above you, then it logically follows that as you ascend, as you increase your height, that column of air above you becomes shorter.
Less air stacked up.
Exactly. There's less air stacked on top of you, meaning the total weight of the air column above you is reduced. Therefore, pressure must decrease as you increase in height. It just has to.
Right. Less air above you means less weight, which means less pressure. It seems, pretty intuitive once you think of it as a column of air. And as the source points out, this concept is so central that the study of atmospheric pressure may be said to form the foundations of the science of meteorology.
It really is the foundation.
Changes in pressure are fundamental drivers of weather.
Precisely. Think of the classic image of the old-fashioned barometer, the falling glass.
Yeah, I've seen those.
A rapid fall in atmospheric pressure is historically and still...
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best